Welcome back, everyone. In this lecture, we're going to have an overview of your exercises for the Matplotlib section. In the next lecture, we'll go over the solutions. So let's go ahead and have a quick overview of the tasks you need to accomplish for your Matplotlib exercises. Okay, so here I am at the Matplotlib exercise notebook. Recall that at the start of this section on Matplotlib, we discussed that really there's two main things we want you to be able to do. And the first one is to be able to actually create a plot and data from an equation. For example, we know the world famous equation E equals mc squared, but what would this actually look like if we plotted out for some values of m? We know that c is the speed of light and it is a constant, so essentially we should have a linear relationship between the mass of an object and how much energy it has. And you should note this is a simplified version of this E equals mc squared equation. You can check out the link for more information, but for this use case, we just want you to be able to plot out the relationship between the energy and the mass of an object. So the first thing you have to do is use your knowledge of NumPy to create two arrays, where m is simply 11 evenly spaced values representing 0 grams to 10 grams. So you should be able to create an array for some masses from 0 grams, 1 gram, 2 grams, etc. And then using E equals mc squared, you should be able to easily calculate the array for the energy in joules held within that mass. And then for part 2, what we're going to do is plot E equals mc squared. So you're going to import Matplotlib, and eventually you should be able to create this plot that shows the mass in grams versus the energy. And also note that the x and y limits have been slightly edited as well as the styling. Okay, so we can see here that even a few grams has many joules of energy. And then in part 3, because we are dealing with such large values of joules, we want you to figure out, and again this is bonus since we didn't exactly show you how to do this, but can you figure out how to plot this out on a logarithmic scale? So again, once you plot this out logarithmically, it should appear curved. So we do expect you to be able to do a plot of just E equals mc squared, and then as a bonus, see if you can figure out the logarithmic plot. So that's the first task as far as being able to plot out an equation. The second one, which is a little more in line with what we do throughout the course, which is creating plots from data points. So in finance, the yield curve is a curve showing several yields to maturity or interest rates across different contract lengths. So essentially, if you're holding a bond or a, for instance, treasury security, then what that means is the longer you have to hold it in order to get your money back, the more interest you should be paid because technically you're taking on more risk by holding it on for longer. So if we actually plot out yield curve data, which is the actual interest rate paid depending on the maturity of a US Treasury bond, then what we can see here is there's 3 lists or arrays already created for you. There's labels and then the rates, the interest rates that is, for July 16th of 2007, and then the interest rates of July 16th for 2020. And the order matches up with the labels here. For the 1-month interest rate in July 16th, 2007, it was 4.75%. For July 16, 2020, the 1-month interest rate was 0.12%, and so on. So you can see here that you have the interest rates and their corresponding labels. So these are all the same length. So once you figure that out, what I want you to do is see if you can plot both curves on the same plot. So this allows you to directly compare the interest rates back in 2007 versus the interest rates in 2020. And note here, the X ticks are using that labels list. So I can see the 1 month, 3 month, 6 month, and so on. And so essentially what we have here are 2 different yield curves. So then we ask you to move this legend that appears automatically inside the plot to be outside the plot. And then the next observation that you can make here in this plot is, while we can clearly see that rates fell a lot between 2007 to 2020, what is not really clear is the relationship between the actual maturities of and between the 2007 values. So I can't really tell how much higher a 1-month interest rate here for 2007 is than, for example, a 10-year interest rate in 2007. So what we want you to do then is split this up into 2 plots. So we talked about creating 2 plots, and here you can see them. So now we want you to show in 2 separate plots the yield curve for 2007 versus the yield curve for 2020. And now I can both compare them and see that the y-axis shows the difference in the yields. And then finally, the bonus challenge task is to see if you can recreate the plot below that uses twin axes. And Keep in mind, this plot actually may be more confusing in real life than it is helpful, but it is a good exercise in Matplotlib control, and you should be able to check out the extra notebook we have there for you that has some hints as far as how you can make a plot like this. So essentially what this shows is the y-axis for blue is on the left-hand side, and the red axis for the 2020 yields is on the right-hand side. So this allows you to try to both compare the curves themselves versus their actual distinct values. Okay, and again, this is a bonus task in the same way that the logarithmic plot was a bonus task. So don't feel bad if you can't figure out this bonus. But overall, what you should be able to do is plot out E equals MC squared for some arbitrary mass values, and then take in these data points for the yield curve, and then plot them out like this, both together, and plot them out separately. As long as you can accomplish those two things, you should be good to go. If you ever get stuck on any step, go ahead and jump to the solutions notebook or video, and we'll happily guide you along there. Thanks, and I'll see you at the next lecture where we go over the solutions.